everybody. We're going to be getting started in just a few minutes. So in the meantime, I think you can see us. You'll enjoy just looking at our smiling faces while we wait. We'll get started in just a few. If you've just joined us, your system is working properly. We're just giving a few more minutes for everyone else to join, and we will get started here in just another moment or two. Well, hello and welcome. We're at an inflection point for financial services firms. Perhaps more than at any point in recent history, there is tremendous pressure to drive transformational change. But because of their legacy of technology innovation, financial services firms are ironically being hamstrung by the technical debt that all of this past innovation has created. Into this gap, a surprising and unexpected technology hero, shall we say, is emerging: the distributed SQL database. Hello, my name is Charles Araujo, and I'm an author, futurist, and principal analyst with industry analyst firm Intellex. Today, I'm here with Arif Kassam, Chief Technology Officer with NuoDB, sorry guys. And together, we're going to tear into this Pandora's box, explain what's going on, and explore why the distributed SQL database may be the solution that financial services firms need to propel themselves forward. Arif, thank you for joining me here today.
Nice to speak with you, Charlie.
So before we get into the kind of meat of this and talk about the hero of this story, I think it's important that we set the stage properly. I mean, after all, you don't need a hero unless there's a villain somewhere. So I sort of set the stage in the opening a little bit, that it's the combination of this need to increase innovation and the amount of technical debt that financial services firms have accumulated that is the villain. But is that what you're seeing?
Yeah, Charlie, you're right, but let's sort of dig into it a little bit more. It's the innovation and demands from customers and competition that's been driving a lot of these changes, right? Customers have gotten used to the convenience and the ease of use of all the social media platforms that exist out there, and they're trying to now apply that to their banking systems, right? They want to have an app to move money, to get money, to look at their balances. And in the competition, some of these fintech startups, they don't have the technical debt that these existing banks do, and so they can move faster. They can develop, they can provide features to their customers a lot faster. And so it's a combination of customer expectations and competition that's driving the innovation. And the technical debt that's accumulated at these existing financial services slows these companies down, so that there is this challenge of to innovate, but being hamstrung by the technical debt that exists in the organizations.
Well, so and you talked about this a little bit. The part of the challenge, right, is that that financial services firms organizations have been sort of on this leading edge, right? They've been leading this charge, but by the same token, would you say that the pace of change of those expectations has actually quickened or gotten, more difficult to keep up with?
Well, I agree with you. I think the pace has quickened. I think everything in the industry has quickened, and the time to market is critical. Being able to capture customers quickly and easily is quickened. So I think this has been a common thread throughout our technology evolution. Is pace of change it becomes a lot faster.
So I want to kind of double click a little bit on this, and we've talked about technical debt, and I know that any of us that have been in the industry, we use this term a fair amount, but just for the sake of clarity, I want to kind of make sure that we're all on the same page. So what do you mean by it, and maybe specifically, why is it such a big issue for financial services firms?
Yeah, so I think it's good to drill down and just make sure we're all talking about the same thing here. Technical debt is a term that we sort of throw around in the industry, but effectively it's something that slows productivity and innovation. It's generally, and I think it's a byproduct of how fast we move in the industry, and as we move faster, the technical debt accumulates, right? And so when you're moving fast, you're making quick decisions. You're not thinking through all the repercussions of those decisions. And so technical debt is a byproduct of those decisions. Maybe you didn't fully think through a particular algorithm or whatever. We said, well, this is good enough for now. Let's move on. And so technical debt starts small, right? You start making small changes, you start making small decisions, but over time it accumulates and becomes a larger piece of the agility, the issues with agility or productivity, right?
But just to be fair, though, I mean, having been on the other end of this, right? I spent most of my career in my early days, running technical operations. It's, I actually have a problem with this term technical debt a little bit, in that it kind of conjures up this idea of, going to Macy's with your credit card and buying all the stuff you don't need and just charging it up. And the reality is we did it a lot of times just out of necessity. We had to respond, we had to move. And that was just the natural byproduct of it, right? But there was almost no avoiding it, right? And so do you see that? But it just keeps growing, right?
Yeah, so I totally agree with you. You need to move, and you need to make decisions quickly, and you consciously make these decisions, right? You consciously make the decision to go with one algorithm or make a particular change or whatever it is, and it's acceptable at that point in time. But as those decisions accumulate, right, over time, you do more and more of these decisions, and they sort of add up. And again, one decision, okay, we can work around it, we can sort of address it, but 1,000 decisions or 100 decisions, whatever it is, that's why I think the debt part makes a little sense in this term, because it's sort of like interest, right? You got to pay it. You got to pay it down
at some point.
And every now and then, we have an evolution in technology that sort of says, okay, we need to pay this down now because something's coming up that we have to get on top of, and we can't do it with the amount of interest that we're paying on the debt that we've got right now.
So, and I think that financial services firms, I mean, this is obviously a problem across every sector that has been investing in technology now for decades. But I think the financial services firm, I mean, I've always been a fan. I've always been an admirer of financial services firms. When I was a consultant, I spent some time working with them, and I was always amazed, just the complexity of the challenges and the pace, and frankly, the pace of innovation. I think financial services firms have been at the leading, sometimes bleeding edge of innovation, pretty much through every stage of technology transformation that we've gone through over the last several decades. But I suspect, based on what you're saying, that also means they probably, this debt problem is probably more significant for them, especially when we combine it with what we talked about a minute ago, as the pace of customer expectations and those changes increases. I mean, is that kind of what you're seeing?
Yeah, no, you're exactly right. Financial services have always been at the bleeding edge. There's a lot of money in that industry, right? And so that money attracts a lot of people, and they move really quickly because they want to capture the market share as quickly as possible. That does have that impact of accumulating that debt, that technical debt, faster. And you're absolutely right that they they are in a unique situation compared to other industries that may move a little bit slower, and so they're in a paradox of having to move fast because they need to capture the market share quickly, and this technical debt that they've got to get around.
So what is driving it today? I mean, what are there specific things that you see driving kind of the technical debt quagmire at this point?
Yeah, so I mean, just a little bit. I mean, we've gone through different phases, as I said, in sort of evolution of technology. There was the mainframe migration to client server. We've had the web revolution. To me, it's the cloud now, right? Cloud is becoming the impetus for a lot of change. Being able to adapt cloud, to use cloud, to migrate stuff to cloud, and that requires different ways of architecting applications, different ways of deploying and managing those applications. And so the inflection point for technical debt coming around now is this whole migration to cloud.
Now, on the one hand, that sounds interesting to say that this is kind of the now thing, because we've been talking about cloud for a long time. Why is it now that you see this as the issue?
We've been talking about cloud for a long time, and a lot like a lot of things in technology, there's always the leading edge, the bleeding edge, right? And so people start talking about certain things before the majority of adopters come along and actually start using it, right? And so cloud, we've been talking for a long time. I think that there is now a critical mass of capabilities, services, security, access, performance, bandwidth, all come together into a critical mass where now the 80% of enterprises are looking at the moving to the cloud, and they're still trying to figure this out. I mean, as much as people in the industry think cloud's passé because we've been talking for so long, right? People are still struggling with this.
Yeah, no, absolutely. I think it's as organizations start taking, going to full scale and actually bringing this to real life, so to speak, that it becomes a much bigger challenge. So, okay, so I think I understand what you're saying about the technical debt and why it's such an issue. But organizations are already dealing with this, at least in part, right? I mean, they have to. And so to do so, they've been doing things like re-architecting applications and moving to things like microservices and containers. So where does the database fit into all of this? And is this what's driving all the conversations about needing to move from like SQL to NoSQL? I mean, that's been a big topic of conversation. Is that where this is landing?
Yeah, so that's a good point. I think the choice of moving from SQL to just NoSQL is sort of a false choice, right? A few years ago, NoSQL came out, and it was sort of the panacea of solving all the problems with typical legacy databases. But as people have discovered over time that NoSQL doesn't fit all use cases. It's a great technology, don't get me wrong, right? I'm not here to knock NoSQL. It works, and it provides great value for specific use cases. But there are certain use cases where NoSQL just doesn't fit. And typically, those are your traditional transactional applications that have been running in enterprises for years that customers are having a hard time to figure out, how do I migrate that to the cloud, right? And so maybe they're re-architecting the application layer, going to containers, as you said, or microservices, as you said, but they're trying to figure out what to do with NoSQL, with their SQL database. And so it's this modernization of applications that's driving people to look for an alternative to their existing SQL database. So,
all right. So first of all, you're not like saying NoSQL has no place. You're saying that there's a place and time for it. But what you're also saying, if I'm getting this right, is it's not just this, hey, if you're going to move to the cloud, if you're going to modernize, throw out all the SQL, move everything to NoSQL. You're saying that it's actually more nuanced than that.
Correct, right? There's definitely a spot for NoSQL. There's a lot of use cases where eventual consistency and availability are more important than strict consistency and transactions and performance on those things, right? There is a gap here where customers are saying, okay, I've been using SQL, my traditional SQL databases for a long time, but it doesn't look like NoSQL will solve the problems. And so that there is this alternative choice that we're providing to these customers with what we call a distributed SQL solution.
So before we get to the distributed SQL part of this conversation, because I think obviously that's the solution, I think it's really important to make sure we understand, because I think the challenge, being an analyst, right? We get all the pitches, we sit through all the briefings, and there's all this hype, there's all this talk about it, and my big bugaboo, having been on the other side, having been sat on the seat of the person who had to try to figure out how to put all this together, is that it's not about good or bad, generally speaking. It's about what's the right fit, how to align this, right? And so I know that when we talked, previously, you talked about kind of the battle scars, the challenges that people had when they would, because I think there was this hype buy-in. It's like, oh, we're going to the cloud. We gotta move away from these old technologies into this new. And then as they did that, they found that it really wasn't that simple. So I mean, what are some of those battle scars? What are some of those hiccups that people have hit, and maybe why didn't NoSQL then actually solve them?
Yeah, so I think some of the battle scars that you talk about is just the trade-offs that with databases, there's different ways you can work around the specifications of how a database works, right? And so with NoSQL, those architectures sort of gave up consistency and went to sort of quote unquote eventual consistency versus compared to strict consistency. They made that trade-off so that they could have this idea of available systems. Again, we're sort of getting a little bit detailed here into the technology, but you have a distributed system, and then there's this famous theorem called the CAP theorem. You can have, under partitioning, you can either be available or you can be consistent, but you can't have both. And so the NoSQL world chose availability over consistency. So they gave up a little bit of their consistency in data to survive outages or to survive failures in a cloud environment. Because now you're moving to a cloud environment, you don't have control over the hardware, and failures could happen, or they will happen. The question is just when, right? And so the NoSQL databases went out and said, okay, listen, I'm okay with losing a log here or an event here, right? It's not financial transactions that I'm worried about losing transfers. So I'll give up a little bit of my data consistency in order to keep the application up and running.
And as you said, there are use cases where that makes a ton of sense, right? And so part of this is figuring out where the use case lines up. But then there's a second issue, is that you mentioned this earlier, that this idea that, well, if I'm going to go to a NoSQL, then I have to re-architect. I have to rebuild that application. And that ends up, and again, having run those kind of projects, that opens up this whole other set of issues, right? And I mean, I imagine you have clients that have kind of gone through that and have, as we say, the battle scars to prove that, right?
Yeah, and so we've already said that clients or customers are re-architecting an application, but they're re-architecting it at an application level, which effectively doesn't really touch the data model, if you will, or how data is managed within that application, right? So they've taken some application logic and broken it up into different types of APIs and isolated the APIs and containerized them, all that great stuff, right? But they traditionally don't look at the data model on how that data is managed, because that's very hard stuff. And now if a customer is saying, okay, I've got to migrate to the cloud, I've got to containerize it, but I also got to take the risk of re-architecting my data model and how data is managed, that just makes that risk profile of that migration 10 times, 100 times worse, right? And so what we're finding is customers are looking for a database that has the same data model and the data consistency rules that their existing database has, but is more cloud native. It works in a distributed environment. It works in the cloud. It's easy to sort of scale out and scale down, as NoSQL databases are.
Right. So let's be clear about one other thing. What you're also not saying. So on the one hand, you're not saying that that NoSQL is the answer to all the problems, but you're also acknowledging that traditional approaches to SQL databases also, aren't well fitted or well suited for the new cloud architectures, right? And so, which is really why you guys exist and what has led to this, this unsung hero, right? So, my keen powers of observation here are kind of telling me that the reason that this was a false choice is because, in fact, there's this third choice that you're talking about. I'm sure everyone is shocked about this. Great plot twist we have here. that the answer is really this idea of this distributed SQL database. So let me validate that, right? Am I on the right track?
Yep, absolutely.
Okay. So, but as you then get into explaining exactly why it's the hero of the story and how it works and what it is, why don't you explain exactly what is a distributed SQL database for those that don't know?
Right. So let's go back to time a little bit, right? So the traditional databases were architected and built out 30, 40 years ago, right? When system architectures were totally different, right? And so these companies built and architected these systems and made trade-offs, just like in any application, they make trade-offs based on the availability of technology at that point in time. And in that point in time, memory and CPU was very, very expensive. And so those systems optimized for I/O. So they did whatever they could to save stuff to disk as fast as possible and retrieve it from disk as fast as possible. Fast forward 30 years, and the compute landscape has changed significantly. Memory's cheaper, like when you're talking about terabyte systems now, CPU's cheaper, and lots of systems with lots and lots of CPU. And so the bottlenecks, the need to get stuff off of memory and onto disk is not there, right? And so the breed of databases that we're talking about, this distributed SQL databases, these are databases that have been architected with modern technologies in mind, the ability to take advantage of more memory than traditional databases had. And the biggest thing is they are distributed architectures. It's not just a single node, right? It's not just a single process, which then you have to cobble together through some sort of replication to get availability or disaster recovery.
So right? I know we don't want to get too technical, but I know we have this diagram on here. Maybe you can just kind of walk us through it, because for me, this is the key of it. If you can understand the conceptual architecture of why a distributed SQL database looks and functions differently from a traditional one, then I think it becomes very clear why it is this third choice and why it sort of sits in between this kind of the spectrum, right? And then we'll talk about, I think, what does that actually help you do? But maybe you can walk us through this.
Yes, happy to, right? So on the left is your traditional database architecture, right? It's a single process that does query processing, query execution, memory management, and then storage management, right? And so it's a single monolithic process that runs and runs your database. Now, traditionally, if you want to make that data highly available, you instantiate a second process and you replicate the data between the two. And there's various replication schemes, asynchronous or synchronous. But at the end of the day, you've got a single point of all your reads and all your writes going through a single process. Now, on the right-hand side is NuoDB's architecture, and that's how there are different vendors in the distributed SQL space, and they've got different architectures depending on how they've sort of made their architectural choices. For NuoDB, what we've done is we've taken the single process of a database and split it into two, right? We've got what we call our transaction engine, which does all the SQL processing, parsing, and optimization, and then we've got a storage manager. So we've taken the approach of most modern architectures, which decouple storage and compute. Right? So we've decoupled the storage and compute, and we've got a compute layer, our transaction engine, and a storage layer, which is our storage manager. And each one of these layers can be scaled independently of the other. So our database is a single logical database represented by that sort of dashed green line. So it looks like a single logical database to the application, but it's made up of multiple processes.
So I refer to the general, yeah, absolutely. And I refer to this general idea as abstraction, right? Where you're kind of being able to create this new layer here. And what you're saying is by doing that, that allows you to effectively map this, as if I'm using kind of the right term here, to the way cloud architectures are set up. And so that allows you to sort of bridge this gap, right? Where you have all the traditional elements of a SQL database, but one that can live peacefully as a citizen in a cloud architecture. Am I getting that right?
Yeah, a little bit more nuance than that. I mean, so when you think about cloud architectures, you got to take into account availability is first and foremost, and the second one is sort of scale, right? I mean, now you've got a lot of vendors providing a lot of different system types, like small to large, very large system types. But in the early days of cloud, you only had small types, small instances, right? And so you had to address scalability through scale out rather than scale up, because those large systems were not available, right? And so the distributed architecture gets you two main things, right? The first and foremost is availability. If I lose a node in a distributed architecture, it doesn't affect the database. The database is still up and running, right? In a cloud environment, the expectation is something will fail, right? Amazon's got racks and racks of people just walking through the aisles, pulling out failed drives all the time, right? And so the expectation is in a cloud environment, something will fail, and you need to make sure you architect something that survives against failure. And the second thing is being able to scale out rather than scale up, right? You just don't have the access to the large hardware that most database vendors require for performance reasons. And so you need something that you can add nodes to increase scale.
So if I can connect the dots here, then what I'm also getting then, based on how you're describing this, is it also solves some of this re-architecting challenge that we've talked about, right? Because it allows you to start getting the benefit of the cloud, of the scaling and performance and things like that, without having to completely re-architect the app because it's using traditional SQL calls, and you have all the ACID compliance and all that. I mean, is that kind of
Yep.
Where this is leading?
Yeah, exactly, right? So from an application interface perspective, it's SQL, it's still transactional, it's still ACID, right? So the entire logic of the database remains the same. But then as you think about re-architecting systems to the cloud, and you want to try to, so a common example is I've built a new application for a cloud, call it a web service, whatever it is, and traditionally, in order to have the database, you'd say, okay, how big do I need to make that database? So let me think about 2 years down the road when I think I'm going to have 1 million customers, and I'm going to size the database to support 1 million customers 2 years down the road, right? And so I've over-provisioned my database because I think that's where the load's going to be in a couple of years. But traditionally, these applications start small, right? 100,000 users or 10,000 users, or whatever. But I've got a system that's over-provisioned just in case, because that was your traditional way of architecting applications. In today's world, what you need is an application architecture that can scale with demand, and that's at all layers. That's at the application logic layer as well as the database layer, right? You want to be able to add nodes as you need scale, or maybe even take away nodes if you don't need them, so that you're optimized the cloud usage as well as your server utilization for the demand when you need it.
So the other thing that strikes me about this is when I was on the other side within enterprise IT, one of the things that always annoyed me was this sense that all this technology is great as long as I buy into all of it and put everything on it all at once, right? Which is just never the reality, right? And so one of the things that I'm very excited about is the fact that we're starting to have meaningful conversations about both hybrid cloud, but also hybrid IT. Just this broader idea that we're going to have the spectrum, and we're going to fit for use, fit for purpose kind of thing, where we're going to put things where they need to go. And so it would seem that everything you're talking about fits really well into this idea of this sort of hybrid approach to how we approach all of this. And so, I mean, how are you seeing those connect?
Yeah, that's a good point, right? So a lot of people think about the cloud as a binary event. There's this idea of all or nothing, that I got to be on premises or all in the cloud. And that's not true. Just like the false choice between SQL and NoSQL, enterprises, customers that we're engaged with, are looking ways to reduce the risk of migrating to the cloud, right? And this is where this idea of hybrid comes in, right? So hybrid is this idea of being able to span an application that's on premises as well as across into a cloud, right? And that provides this sort of cloud on-ramp, as we sometimes refer to it, is a way to transition from an on-premises environment to a cloud environment. And we've seen a lot of different use cases, right? Some customers are using this hybrid model to burst into the cloud for load that they weren't originally planning on, that then they say, okay, I need more resources, let's spin up stuff in the cloud because it's faster. And so they use it for burst performance. We also see customers using it as a DR or HA strategy, right? And so I've got my data in my on-premises system, but I don't want to have another data center, so maybe I'll use the cloud for DR or HA drivers. There's a number of use cases where hybrid cloud is sort of addresses, and I think it's going to be the rule, not the exception. in general.
Yeah. I agree. I think it is going to become the reality that we're really dealing with, and I think it's the right one, because it's about, like I said, it's about aligning your technology to the business drivers, and not not basing your decisions on the technology, right? It's focusing on what's going to solve your business problems. But what I think is really interesting about that is I think that it's both liberating and probably daunting a little bit, insofar as it requires people to start thinking about this a little bit differently. And I think specifically, so what I'm curious about is, when you think about financial services firms, and I know you do a lot of work with them, how is this part, this specifically, both not only the hybrid evolution, or the evolution to this kind of hybrid approach, but also how then they're applying distributed SQL databases into that hybrid environment? How does it specifically affecting financial services firms?
Yeah, so what we're seeing is like the rest of the industry, financial services firms are migrating a lot of stuff to the cloud, and the ability to do that in a transitory rather than a one-shot binary move is very attractive to them, right? They can experiment. They can put a few nodes of a distributed database into a cloud environment, make sure everything seems to be working fine, and slowly migrate things over, rather than a all or nothing type of gamble, right? And so some of these financial services firms are looking to the re-architecture and migrating to the cloud to help them actually even move to the cloud, if you will, if you think about it, right? They're re-architecting this application, maybe still running it on premises in terms of containers, but then that containerization also helps them push pieces of the application to the cloud. Right? And so there's a sort of relationship between moving to the cloud and re-architecting that it works for both the on-premises and cloud architectures.
Well, and I think it sort of ties into the technical debt conversation we had at the beginning, right? The more technical debt you have, the more agility or flexibility you need to sort of unstick that, right? To be able to make these transitions without having to do the all or nothing. And I think when you have a lot of technical debt, that is the somewhat false choice again, right? That it's like the only way I can get out of this is by trashing it all and starting the whole thing over. And what I see with this is this now suddenly starts providing some additional pathways forward.
Yep. So the technical debt, and you made, again, we've talked about this earlier, is that we don't want to put out there false choices or binary choices, all or nothing, or SQL or no SQL. Like you said, it's what the business is driving towards. And the business is always about reducing risk. So they need to pay down this technical debt, but they need to do it in such a way that it reduces the risk of that whole migration or that whole re-architecture. And so they're looking for modern systems that help them in the new architecture, but don't throw out the baby with the bathwater, if you will, right? They want to be able to still have their SQL transaction, their ACID, their consistency that they're used to and expect, but still get to the next generation of systems to help them move forward.
Yeah, it's funny. I was talking to an executive not too long ago, and around this subject, and he sort of said something to the tune of like, well, don't organizations just need to be ready to move to the future, quote unquote. And what I think is interesting about that, and it belies this kind of undercurrent that anything that's old is useless and worthless. And what I advise everybody is that the name of the game right now is speed, agility, and flexibility, right? The ability to be adaptable and to pivot as markets shift. And right now, if I look at these financial services firms, right, so much technical debt, so much hardened assets, so to speak, that it's about how do you make that so it's more fluid. And what I see and what I love about this technology is that it allows that. It gives you that sense of flexibility and agility without having to re-architect everything and take, frankly, all the risk and cost associated with that. And I don't think it's one-stop shop. I don't think, and as you've already alluded to, it's not the answer to every problem, but I think it's a very valuable and important part of the kind of arsenal that enterprise leaders need to be figuring out. I mean, are you seeing that your customers are using it in this way?
Yeah, exactly. And obviously this is the reason we're in business, and we have customers that are we are targeting and are attracted to using us is because they have this need, and NuoDB provides this capability that they are looking for to get them to the next generation of architectures and next generation of capabilities, exactly for the speed, agility, and being able to move as fast as possible without incurring a significant amount of risk.
So we're going to be taking questions in just a few minutes. So if you have any, based on what we've talked about so far, there is the facility here in GoToWebinar to go and put the question, and we're going to answer as many of those as we can. So please start thinking about those questions and getting them into the system. But in the meantime, Arif, I want to thank you. I mean, I think this has been great. I think you've really helped us understand the situation that every organization, but specifically financial services firms, are facing. And I think I can safely say, not to be too cheeky about this, but the distributed SQL database should be wearing a cape out there. I mean, it's the hero of the story. But I know that we've only really scratched the surface, right? There's so much more to explore about both the technology itself, but also specifically how financial services firms are using it to overcome some of these challenges that we've talked about and moving towards this hybrid future. As I joke, enterprise IT folks, we love to cheat on each other's homework. So, if we can figure out how other people are doing this and solving some of these problems, we want to go learn from that. So if anyone who's watching would like some more information, either on kind of the technical nuts and bolts, or maybe some of the use cases that you guys have some experience with here, where should they go?
Yeah, that's a great point, Charlie. So up on the screen there is a URL for financial services. So we've got a number of resources, use cases from existing banks that we currently work with. They're using NuoDB and its SQL, and sort of the benefits that they're seeing of using NuoDB. And I'm sure there's a lot. There's could be practitioners in this call, developers or DBAs. We also have a free community edition that people can download, try, and play with to see the benefits of scale out and availability with our free version.
Fantastic. So some great resources there. And then let's go ahead and we're going to spend our last few minutes here of this call or of this webinar with some questions. So if you have any, please again put them in the question box there on GoToWebinar, and we will get them answered. I mean, if we don't get through all of them, the folks at NuoDB will be following up to answer them offline. But we have several here now already, so let's get going with it. Arif, buckle in. Some of these are some doozies here, so let me read them here. So first of all, what are the most common applications that financial services organizations are deploying your database for, and why?
So I sort of alluded to this, right? One of the big banks in the UK, they want to move to the cloud. They're still running on premises, but they're leveraging NuoDB's distributed architecture specifically for availability, right? These are applications, these are critical applications that can't have any outages, right? And so they classify them as tier 0 or category 0 applications. And NuoDB is the database of choice. It's the database that they've certified for these mission critical applications, right? There are other applications that don't need as much availability, and they've got other database vendors that fill that gap. But for financial services where these applications have to be up all the time, NuoDB is the database behind those applications.
So it's interesting. I'm sorry, go on.
No, so that's one aspect. There's again, we talked about scale out and containerization are another aspects that we've got. So if you got a follow-on question there.
Okay, well, I was just going to say what's interesting is that example both talks to, I think, this hybrid idea, right? It's not all or nothing, and this idea of dealing with the challenges of how you migrate, and so where they didn't have to re-architect to solve this DR problem, right? It was a way to solve it without having to do that. So I mean, I think it's a great example.
Exactly.
So let's see, go to the next question. Is there any technology that fits really well with a move to the cloud in your distributed database? So I guess that's sort of a version of the last question, right? But is there a specific fit here?
Yeah, so just looking from a technology perspective, again, we've talked about this, right? Technology is moving quicker and quicker and quicker every day, right? And I think there's some interesting innovations that are happening, and the cloud, quite honestly, makes it easier for consumers and customers to consume those technology advances, right? Because they get the latest and greatest technology into their centers, and sometimes you get previews of those technologies. I think there's some interesting things that are coming down the road, specifically from Intel on their high memory, non-volatile memory systems. I think that they've got a platform now called Optane, which we've been working with internally and working with Intel, that changes the game on, yet again, performance characteristics and the ability to have memory level speeds and almost get rid of I/O altogether for certain types of applications, right? And so as customers are looking at re-architecting their systems and trying to figure out choices, architectural choices of what to do with data, I think there's some future technology that's coming down over the next few years that will make performance significantly better and be able to address a lot of different sort of use cases based on the non-volatile memory that's coming in.
So, actually, it's a really interesting point that we've been talking about this, and so this is just my follow-on question to that. But when you talk about using NuoDB to help move to the cloud, is that your cloud? Is that any cloud? I mean, what exactly do you mean by that?
Yeah, that's, again, a good point. So this is move to any cloud, right? And actually, another customer has selected NuoDB specifically because we're cloud agnostic. In Asia, there are financial regulatory pressures to have a multi-cloud strategy, right? These regulatory pressures are saying you can't have all your data in, I'll just pick one, AWS, right? It's just in case something happens in AWS, you need to be able to get your data out of there or get access to the data. And so these regulatory pressures are forcing these vendors to have a multi-cloud strategy, or even just from a business continuity strategy, they want to protect themselves from any outages from one service provider. And so they're using a multi-cloud strategy, right? And so NuoDB provides a cloud agnostic solution. So we run in any cloud, on premises. So we talk about hybrid, we talk about on premises to cloud, and we also talk about multi-cloud as a solution for its customers.
Okay, great. So another follow-on question, or sort of follow-on, does NuoDB have store procedures like other RDBMS products in the market, such as Oracle and Microsoft SQL?
Yep, we support generic Java as well as SQL store procedures. We have indexes, we do joins, so it looks and feels like a traditional database, a traditional SQL database, a relational SQL database. And so it's fully functional.
Any limitations that, I mean, to kind of follow that question, that someone should be aware of?
Nothing specific. There's in any distributed architectures, you always have to think about how data is placed and how data is moved around in a distributed environment. And so I don't think you could take an existing application running on Oracle and move it to NuoDB without any issues. But then there's optimizations that you can do to improve performance as you think about how data is placed and used and replicated in the environment. Yep. And so there's no specific limitations that they have to be worried about, but there is advantages that they can take advantage of.
So it's kind of that next level. Okay. All right. So here's another question. How are banking software products and platform providers responding to distributed database needs? Are they partnering with you or creating their own distributed databases? Good question.
So again, a great question. So I think the industry is now learning about. We're trying to educate them about this third option of distributed databases. We do have an existing partner, a company called Temenos. They are a financial services software provider. So they provide core banking software to banks, specifically in the Asia Pacific, South American regions, as well as the US. And we've been partnering with them to certify and provide NuoDB as the distributed database for their software application. So banks effectively have the ability to deploy a core banking system with a database that's already part of a distributed cloud native architecture.
Okay, great. So let's see, here's another question. I'm not sure if this one's tongue in cheek actually, but how are banks moving to the cloud? Is it typically all in one go, or do they take a more gradual approach? I'm curious. Do you have anyone that's any bank that has gone all in one? I'm just all boom.
Yeah. No, yeah, you're absolutely right. There's nobody who's willing to take that risk, right? It's all about a hybrid approach, an incremental, put some nodes of application in the database in the cloud while it's still running on premises, make sure performance, make sure availability, make sure all the stuff works as needed, and then as they move, they sort of migrate, right? And so we've got, again, a number of banks at this time in the UK that are taking this container native approach. They've re-architected a lot of applications on premises from a container perspective. They're bringing the database into, and we didn't really touch on this, but so Kubernetes, right? So Kubernetes is yet another technology that's popular. We fit very well within a Kubernetes architecture, and so they're taking these databases, migrating them to NuoDB within a Kubernetes cluster, right now all on premises, but then moving to Azure is the next step, right? And so again, they're setting themselves up. They're sort of building the building blocks to sort of pay down the technical debt and then get ready for that whole cloud shift.
So this is my follow-up to that question then. So on the one hand, I think that, well, I agree. I haven't heard of anyone across any industry just like diving and, it's just not practical. But we are seeing a couple of variations on this theme, right? We're seeing people that are taking a much more tactical sort of approach, and then where it's, project by project, initiative by initiative. And then there are some that are basically going, quote unquote, cloud first, right? That everything is going cloud, and then it's this kind of migratory process on the back end for the quote unquote legacy. Are you seeing how organizations are leveraging you? Are one of those approaches more prevalent for when they would be a good fit for you, or do you play differently, or are you a tool in either case?
We work in both cases, and interestingly enough, I'm also seeing sort of the dichotomy of a cloud first top-down paradigm versus project by project. I think it's based on the company and what they're comfortable with, and where they're at in their maturity of technologies and capabilities, right? I think traditionally, if I had to sort of broad stroke it, typically with those companies that have got a lot more technical debt, that are a little bit slower, we'll do project by project. Those companies that are always more at the forefront of technology will get sort of a cloud first push down from the top, saying this is where we have to go, so let's just make it happen, right? And so those types of companies have always been at the forefront of technology and are used to sort of the sort of top-down initiatives to drive them that way.
I think you may have answered this next question already, but I just want to make sure we're clear on it. So the question is there a developer community edition of NuoDB available so that developers can try it out?
Yeah, so that was the link here. The download free community edition is our version that's available for use for free. It has certain limitations in terms of the number of nodes it can scale out to, right? But otherwise, it is a totally fully functional, fully available system for free.
Okay. And I think we have time for one last quick question, and it's a little bit meaty, so hopefully you can answer it relatively quickly. But picking up on actually my follow-up question about where you talked about them being cloud agnostic, the question is, well, what exactly does that mean, and how does it actually work?
Yeah, so NuoDB is a solution that works in any cloud, right? So we've architected it such that we work with different storage backends, whether you're talking about Amazon EBS or local volumes in Azure or whatever it is, right? So we've architected it such that we don't rely on specific types of technology that are only available in a cloud provider. And so this is software that you can run in Azure, in GCP, in Google, and Alibaba if you want, right? And so because it's sort of cloud agnostic, that opens up, that provides customers with the choice. So every customer's got their cloud of choice for whatever reason, whether it's competitive reasons or it's just where their developers like to run stuff. Every customer's got their choice of whether that's Azure, GCP, or Amazon, and that's going to continue, right? You're always going to have multiple cloud providers because one is competitive pressures to keep prices down, and two, that each one's got their own set of benefits. And so we run in any one of those. And as I mentioned earlier, we do have a customer that's running across, in this case, Azure and AWS, right? So they want to be able to make sure that their application works across both and their data is available in both in case of either a service outage or for regulatory pressures.
All right, and good job. You did that in the minute we had left, so thumbs up, way to go. So, all right, well, that is all the time we have. It has been an absolute pleasure chatting with you, Arif, and I'm glad you were able to join, or we could join together for this webinar.
Thank you, Charlie. I appreciate it. It was very fun.
All right, with that, I'm Charles Rajo, and for myself and Arif, thanks for joining us.
Thank you.